just looking at some exact angles, and I just want to look at them in radians, and we'll look at some of them in degrees, but we're mainly focusing on the A plus B and the A minus B expansions. So if we want to find cos of 7 pi on 12, that's 7 times 180 on 12. Okay, so basically, if you look at that, what angle is that? Put that into your calculator, and you end up with 105 degrees. So it's cos of 105 degrees. Now, which exact angles is that a combination of? So it would be the, not the 30, so it'd be the 60 and 45. Because if you did 60 plus 45, so 60 plus 45, that would give you 105. And that's a cos expansion. So it's cos, so it's cos 60, cos 45. And if you've got a plus sign, then sine will be the same sign, cos will be different, so cos will change in the middle. So it's cos 60, cos 45, sine 60, sine 45. And then all you got to do is just evaluate that exactly. So using your exact triangles, so cos 60 is a half, cos 45 is 1 on root 2, minus sine 60 is root 3 on 2, and sine 45 is 1 on root 2. So you end up with 1 minus root 3 over 2 root 2. You could then go on and just rationalise that. You get root 2 on the first one, and root 3 times root 2 is root 6. 2 times root 2 squared, so 2 2s are 4. Okay. Alright, so if we look at the next one, okay, we need the triangle for A, so that's a half, sine A is a half, so that's 1, 2, so that would be root 3, and it's in the first quadrant, so it'll be positive, and sine beta is 1/5, so, and it says that cos is negative, and sine is positive, because its sine's equal to 1/5, so it means it's in quadrant 2. And if that's B, sine, that's opposite on hypotenuse, so that's 1 on 5. So it'll be 25 minus 1, which is root 24, which is 2 root 6 when you simplify it as a surd. Okay, so now what we're interested in doing is finding sine A plus B. So sine A plus B, sine goes to sine A cos B. And sine keeps the same sign, so it's sine B cos A. So if you look at those triangles, sine A, using the sine triangle, which is this one over here, sine A is equal to 1 on 2, and cos B, which is, let's just do, so the cos B, so the B triangle's here, so cos B is 2 root 6 over 5, so it's 2 root 6 over the 5, plus sine B, so sine B is using this triangle again, so that's 1 on 5, cos A, and cos A is using this triangle over here, cos A would be root 3 on 2. Okay, so we have 10 on the bottom, because they both have denominators of 2 times 5, which is 10. On the top of this one, that's 2 root 6 plus root 3, and that would be about it. Okay, now the next one's, when you look at these, look outside the square, that's cos, sine, so you need to put it back in, so it's going backwards, back into the cos rule, so it's cos A plus B, so that means it's cos 90, and cos 90 is just 0. This is a sine, cos, so that would be sine keeps the same sign, so 20 plus 40, which is sine 60, and sine 60 is root 3 on 2. Okay, for this one here, we've got cos, sine. So let's get them with the same denominator for that 3. So that would be cos of 7 pi on 12 plus 4 pi on 12, which equals cos of 11 pi on 12. Okay, so what we're going to do is actually reduce it, and maybe it's easier changing it to degrees, but you're trying to reduce it. It'll be in that quadrant. like it's pi minus pi on 12. So it's cos of pi minus pi on 12, which is pi on 12. But the problem is because it's in that quadrant, the cos is negative. Now I'm just going to change it to degrees because I think it'll be easier to see the next step. Okay, so if you did 180 divided by 12, you get 15. So it's going to be minus cos of 15. You could also take it all the way back to here too if you had trouble realizing that it was in the second quadrant. So if you did 11 times 180 on 12 times 180 divided by 12, you end up with 165. So that's cos 165. It's in that quadrant, so it's the same as cos 180 minus 15, and it'll be minus cos 15 because it's the same as cos 15, it's just in the other quadrant, and it's negative because cos is negative in that quadrant. Okay, so we're doing minus cos of 15. So minus cos of 15, now that's a combination of cos of, we go 45 minus 30. So then we can use the a plus b expansion on that. So that's minus cos 45, cos 30, because cos is cos, sine, because it's CC chips. Sine, same sign, cos is different. So if that's a minus there in the middle, then that means this middle is going to be a plus. So it's going to be sine 45, sine 45, it's not cos, it's sine, cos, sine. So it's sine 30. So that's going to be minus. Cos 45 is 1 on root 2. Cos 30 is root 3 on 2. Plus sine 45 is 1 on root 2. And sine 30 is a half. So altogether then that is minus, it's root 3 plus 1 over 2 root 2. You could rationalise times root 2 times root 2. So it's minus root 6 minus root 2 over 2 times 2, which is 4. So the final answer is minus root 2 minus root 6 minus root 2. And it will be root 6 minus root 2 all over 4. The root 6 and the root 2 comes from expanding, and the minus, I've got these two minuses, comes from when you open the bracket. That will change the sign in the middle and the sign out the front of the root 3.